Hi everyone, very good evening to all of you. Today we are going to talk about how ISRO has successfully carried out the controlled re-entry experiment for the decommissioned MT1 satellite. What is this controlled re-entry? What do you understand by this? We'll be talking about this. So my name is Ashna Sisodia and let's start with the session. So ISRO has successfully carried out this controlled re-entry experiment for MT1 satellite. What is this satellite re-entry? What do you understand by this? Satellite re-entry means controlled or uncontrolled return of a satellite to Earth's atmosphere, and it can have several benefits. Sometimes, for the disposal of space debris, this is done because satellites that have reached the end of their operational life can be intentionally deorbited and allowed to burn up in Earth's atmosphere. This is actually a safe way to dispose of the satellite and prevent it from becoming space debris that could pose a risk to other satellites and spacecraft. Also, some satellites are designed to re enter the atmosphere and land on Earth, which carries scientific experiments or samples collected in space. So, this can provide valuable information about the effects of space on materials, on biological organisms, and other objects. And this also involves cost savings because satellites that are no longer needed in orbit can be re entered and destroyed rather than being left to orbit indefinitely. And this can save on the cost of maintaining or replacing the satellite in orbit. Satellites which are designed for re entry can be used as part of missions to explore other planets or celestial bodies. Like, for example, NASA's Mars rovers have used heat shields derived from satellite re entry technology to protect them during their descent to the Martian surface. So overall, we can say that satellite re-entry can be a useful tool for managing and conducting scientific research, reducing cost and supporting space exploration. So, what is re-entry? I told you that this is all done to reduce the number of non-operational spacecraft and spent rocket upper stages orbiting the Earth. And one method of post mission disposal is to allow the re entry of these spacecrafts either from natural orbit decay, which is uncontrolled, or controlled entry. But this one was a controlled entry. Now, what are the methods of doing it? There is uncontrolled or controlled entry. Uncontrolled is also known as orbital decay. So, one way to accelerate orbital decay is to lower the perigee altitude so that the atmospheric drag will cause the spacecraft to enter the Earth's atmosphere more rapidly. However, in such cases, the surviving debris impact footprint cannot be guaranteed to avoid inhabited landmasses. And a controlled entry normally is achieved by using more propellant with a larger propulsion system to cause the spacecraft to enter the atmosphere at a steeper flight path angle. The vehicle will then enter the atmosphere at a more precise latitude and longitude, and the debris footprint can be positioned over an uninhabited region, and generally, this is located in the ocean. So, what exactly is a space debris? Space debris encompasses both natural, meteoroid, and artificial, that is, human made orbital debris. You know, space debris is also known as space junk, which means man made objects that are orbiting the Earth, but they are no longer serving any useful purpose. This includes discarded rocket stages, defunct satellites, and other debris that has been left in orbit as a result of space exploration activities. Space debris can range in size from tiny particles to large to multi-ton objects. But these days, space debris is a significant problem because it poses a threat to spacecraft and satellites in orbit. Even small pieces of debris can travel at high speeds and it can cause serious damage to spacecraft upon impact, which can lead to mission failure and loss of critical services provided by satellites such as communications, navigation, weather forecasting, and this can even threaten the safety of astronauts on the International Space Station. And in recent years, the amount of space debris has increased significantly due to the continued use of space for commercial and military purposes. So these are the threats involved. Under that, even a tiny paint flecks can damage a spacecraft when traveling at these velocities. In fact, multi-meter sized orbital debris represent the highest mission-ending risk to most robotic spacecraft operating in low Earth orbit. In fact, in 1996, a French satellite was hit and damaged by debris from a French rocket that had exploded a decade earlier. Then in 2009, a defunct Russian spacecraft collided with and destroyed a functioning US Iridium commercial spacecraft, and this collision added more than 2,300 pieces of large trackable debris and many more smaller debris to the inventory of space junk. In 2007, anti-satellite test was conducted by China, which used a missile to destroy an old weather satellite which added more than 3,500 pieces of large tractable debris and many more smaller debris to the debris problem. But how ISRO did it? Well, this MT1 satellite was actually launched in 2011, and since last year 2022 August, the satellite's perigee was progressively lowered through a series of 20 maneuvers. The final two deboost burns, they were executed on 7th of March 2023 this year, and the final perigee was estimated to be less than 80 kilometers, indicating that the satellite would enter the dense layers of the Earth's atmosphere and subsequently undergo structural disintegration. From the latest telemetry, it is confirmed that the satellite has re-entered the Earth's atmosphere and it would have disintegrated over the Pacific Ocean. This mission operation complex is in ISRO telemetry, tracking and command network. So in recent years, ISRO has taken up proactive measures to improve the compliance level with the internationally accepted guidelines on space debris mitigation. Efforts are underway to build indigenous capabilities for tracking and monitoring space objects to safeguard Indian space assets. An ISRO system for safe and sustainable space operation management has been established to spearhead such activities. And these controlled re-entry exercises bears yet another testimony to India's continued efforts towards ensuring the long-term sustainability of outer space activities. This is it for this session, guys. Thank you very much. Bye-bye. Take care.